Hello everyone, today we are going to talk about how to calculate some stairs. So here we have a picture of some stairs in rough construction. First of all, just some information about stairs. We can talk about their ergonomics or their comfortability is the way I like to think of it. Stairs are comfortable to go up and down if they are somewhere between a 30-degree and a 35-degree angle. Ideally, we like to have a 7 to 11. What that means is it's going to go up 7 inches up and 11 inches across. So every time you go up 7 and 11 across. If you have something a little bit more than this, it tends to get too steep and then it's hard for us to get to the top. Or if it's too small, then it's one of those stairs that seems to go on and on forever. 11 is ideal because that's the size space we have for our foot to land, and for some reason 11 inches tends to be what most people can handle. If you have it too small, then your feet don't fit on that step and you tend to trip more. If they're too big, again, sometimes you'll find the smaller people having to take 2 steps on a single tread. And that's what this tread is called. It's the space for our foot. Okay, there are rules that we have to follow. The maximum height that a step can go up is 7 3/4. Unless you're in Wisconsin, they do allow us to go a little steeper. In Wisconsin, we can go 8 inches, and we can go as small as 9-inch tread in Wisconsin. One thing to kind of remember is when you're counting these, we always have one tread less than the risers, because if we go up, we have a tread. Go up, we have a tread. Except when we get to the top, we're going to go up and then we're on the floor. So we don't have a tread necessarily for that last step. So we want to remember that we always have one less tread than a riser. So I'll write that down for you guys. This PowerPoint is in our Blackboard site, so you can get it there. So you can print that out and write these little notes alongside. I'm going to go through them a little quickly because everything is kind of written out for you. So again, we already did this. Note that we do have one less tread for a riser. So if we have 8 risers, we will need 7 tread. All right, the total rise. I should zoom in a little bit, maybe that'll make it a little easier to read. The total rise on these is from the very bottom of the floor, so I'm going to go back up to this picture, to the very top of the floor. So that's going to include any flooring material that you have there. So to do this, here's my total. What we want to do is calculate the total rise. So we have that the framed walls are 97 3/4. We're going to have a 14-inch floor truss. So I'm going to kind of point that out. Here's our from floor up. There's our 97. Our floor truss is what the floor sits on, so it's kind of sitting in here. That is going to be our 14 inches. We have a subflooring, so that's the little plywood that we lay down to put under our flooring. That's going to be 7/8 of an inch thick. And then we're going to put some 3/4 inch flooring, so that could be like carpeting or linoleum with the pads and everything. All of that added together is going to give us that 3/4 of an inch. We want to report this total rise to the nearest 1/8 of an inch. So in other words, we need to take all those pieces and add them up. So doing that, there's our 97 and our 14, that's 7/8 and so forth. The thing to remember here is to keep track of the inches and the fractional parts of an inch, and we can add those together. And we've learned how to add fractions together. Now to calculate how many risers we're going to put in there will depend on how high those steps are going to be. So let's say we have this total rise, so new number here, 123 3/4. Notice it is different than the example we did before, so we're starting with a new problem, 123 3/4. And we want to calculate and have a 7.5 inch rise. So we want to go up 7.5 inches. every single time. So there's another 7.5. 7.5. And we want to know how many times we can do that in this total 123 3/4. Okay, to figure that out, we're going to basically take this distance and chop it up into those pieces. Or we're going to take that 123 3/4 as a decimal, divided by that 7.5, and we will get 16.5. The thing to remember here is when we get this value, we will always round up. And the reason for always rounding up is because we want to make sure that we don't get too steep. If we round down, that means we're going to have one less, and we have to make up that extra distance with making these steeper. So we want to make sure to always round up. There is another method here, but I find this one to be a little bit easier to do because it makes sense to me to take this total distance and round it up. So we're going to need 17 steps. So if we need 17 risers, so in other words, we're going to rise 17 times, we will need 16 tread. To remind us that every time we have a rise, we have one less tread. Okay, going on a little bit more, we're going to skip that practice. I'll let you guys do that. The next thing we do want to do, and I'm just going to go back to this one we just had. Let's say we had these 17 rises and our 16 tread. And the next thing we wanted to know is how far the total run is, our total run. Okay, so based on this height, which we may have had to calculate, and finding out how many risers we had, so we needed 17 risers, so 16 tread, and let's say that each tread was going to be our standard 11 inches. We can find our total run, because here would be 11, here would be 11, here would be 11. We'd have one less, so we would take that 16 inches, multiply it by 11 inches, drag out my calculator. 11 times my 16 is 176 inches, which is a lot. So I could, if I wanted to, turn that into feet and inches. So dividing by my 12, I get that 14 feet. And I'd have 8 inches left over. Okay. So 14 feet, 8 inches out of my 176. So these are the types of things that you will be doing. And please make sure you go through the entire PowerPoint and go through all the examples. The work is shown on all of those so you can figure that out. But the thing to remember is every riser, there's one less tread. This is going to be your total rise of that staircase. The total run of the staircase is from where that last riser comes up, straight down from there all the way out how far it goes. So then we will know if we have enough space to put it into our basement. We don't want to make sure to not run into a wall, so that's why sometimes you'll have these landings and a turn going down, because you don't want to end up creating steps that go into walls and you can't get out of them. So a lot of thought does go into staircases. Okay, good luck, and I will see you online. Ask questions through email if you do have any when you're working on these. And again, good luck. There is a worksheet out there for you to work on. So thank you.